This is code.org, and we're going to be starting our Pattern Painter class, which is going to be great. First, we need to import Painter Plus, so backpack a poo, click a poo, and hit import. Cool. Like always, students, if you're missing this for some reason or it's broke, you got to hit new file, name it Painter Plus, and copy over the code, or you could just commit the code and move it that way. Regardless, onward with this. So we need to create the Pattern Painter class. Create a new Java file called patternpainter.java. New file, cool. And we have to name it exactly that, right? Pattern, capitals matter, all the details, and I'm misspelling it while I'm saying that. Pattern Painter, you need the .java, capital P, we're good to go. Blop. All right, what do we got to do now? Import the neighborhood package on the first line using, so this would actually import the entire thing. The asterisk means it would import everything in this package, but that's fine. They want us to be more specific. So I deleted the asterisk and threw on Painter. Write the class header for the Painter Plus class, which is a subclass of Painter Plus, of Pattern. Okay, so class header, guys, I'm going to head over to Painter Plus because we have a ton of examples at our fingertips if we're unsure about something. They might have even done, yep, let me see, show me how. Hey, look, they even helped us out here. This is perfect, actually, exactly what we want. So public class, yeah, we don't even need to look at Painter Plus. I mean, we could, it has this layout as well, but perfect, they give it to us. So public class, and then what's our subclass's name? Well, the class's name I know because it must exactly perfectly match the file name, just not the .java. So I know my class name, it's pattern, pattern painter, right? And then it extends, and they told us, right, what's its parent class? What is Pattern Painter going to be built on top of? Painter Plus. Cool. And it's a class, don't need that. Do need curly brackets. So great. This tells the computer this is our class, Pattern Painter, and it's built on top of Painter Plus. What else does? Oh, that's really nice. Oh, look, they even give us the constructor. So this is what we're going to have to do next. So why not take a look at this example and do it right now. I'll hit enter twice just for formatting, and then we're going to do public, and this constructor is exactly the same as the class name, so just like this was the same as the file name. Pattern Painter, parentheses, 2 curly brackets. And then inside of this, we're writing the word super and semicolon. What does that do? What is super doing? Well, when the computer runs this, it should be creating a Pattern Painter object. And what is the object? Well, it's going to be able to do whatever code we put here, but the computer also runs super, and computer says, what in the heck is super? What is above this? What are you asking for? And it starts to hunt. And it goes smack, well, it's a class, okay, Pattern Painter. Oh, it's extending. So it's built on top of, oh, so what's above it? Painter Plus. And what this does, super, is it grabs everything Painter Plus can do and lets Pattern Painter do that. The really cool thing about this is it's like a double stack towery thing, because Painter Plus is extending Painter, which means Pattern Painter, if it extends Painter Plus, not only does it can do everything Painter Plus can do, automatically with Super now, it can do everything Painter can do. All right, cool stuff there. And we got that now. Write your method to create the pattern that you planned on your Pattern Painter handout. Yeah, so my students, you might have a paper copy of this, you might not. Regardless, keep in mind the classes or the methods here that we can use while doing this, and pseudocode. I hit this every time, I'm going to now. Pseudocode's a real thing. It's not like a boring thing to be cruel to students. Go work at Google or Microsoft or wherever you want, make $1 billion, buy me a boat. But also, you'll do this. It's how cooperative planning works. It's how brainstorming sometimes works. It's a thing that you do. You're writing code in normal language to some degree, but still formatted as code. All right, what we're going to do on this portion is paint pattern. Since I want to demo this as I go, I'm going to put my pseudocode as we go on the code side. But I'm going to grab this, just a copy, and head back over here. So I'll throw my pseudocode in a comment down here because I want to be testing this as we work. I find that more beneficial, especially in tutorials. So bam, we got that. I know I need to paint a pattern. Before doing this, I want to say I'm going to follow this exactly. It kind of drives me nuts because notice they retrace their steps at one point, right? So the painter is going to start out up here, and goes all the way around and then ends up on that same square that we already walked on, and then walks on another square we already walk on before moving over to here. That's fine. I would do it differently. I would make the painter turn and go down, over, up, and then over, so it never retraces. But I think it's good to have a tangible example. I'm going to be following this exactly. That all being said, let's get some pseudocode in here. Pseudocode, guys, one, it's in your own words. You want to think of it as for someone younger than you want it super simple, but to resemble code. So what are my steps here? Well, to create the pattern I want, I would start by, painting. So paint. I'll call it a dot, I guess, because I don't want to say square since that's our shape. So paint a dot, and you might disagree, you might do square, you might want a different order, but yeah. And then move forward, right? And then, so we have an option here. We could turn or we could paint. Let's go ahead and turn and then do the painting, because I think we could, let's see. Turn right, hopefully. My directions are not awesome. Well, my directions, as my students know, are perfect. Students don't bring that up. I just mean left and right. Ooh, yikes. All right. And then, so I'm going to move forward, turn right, just getting ready to face this way. But then I need to paint that square. So, dot. And then what? Well, now I would need to move to the next. Okay. And honestly, we're just going to keep going. It's a square, so. So guys, I just kind of threw this in here, but at first, I'm just going to go around and paint. So that will get me back to here. But I said I want to do what they are doing, and it looks like their painter ends up back where the painter started. So obviously we're only doing paint pattern, not the whole row thing yet. But I want to get my painter back to where they started. Let's see, though, how this runs. So, and it is a square, so notice paint a dot, right? Bloop, move forward, bloop, turn right, zoop, paint a dot, bloop, move forward, because I'd be facing down, bloop, turn right, bloop, facing this way, paint this dot, bloop, move forward, bloop, turn right. I don't know why bloop is paint, but it is. Turn right, and paint that dot. Let's see if this all works. Let me get this in code form. First, we need our method signature, and that's a fancy way of saying writing the method name, honestly. Just like when you do your signature, it has your name. Unless you're forging your mother's on a permission form, don't do that, I'll catch you. Public void. I'm doing public void because, honestly, go back to these other classes and look. This is how we've been starting our method signatures. We'll get more into it later, but it's the access modifier and it's the return type. That being said, public void, now the name of the method, paint pattern. And then it does have a parameter, string color. That just allows us to select a color when we ask the method to run. And then curly brackets. All right, there's our signature. Let me just throw this code in here. And it's great. I have a roadmap. I'm going to use the word color because remember, the variable's going to be used to set whatever color they want to use. And we don't use dot notation. We're inside the PatternPainter class, and that has direct access to Painter Plus and direct access to Painter. So there's no object. We can just run the methods as is. Okay, so this is my pseudocode pretty much exactly just in code words, right? Paint, color, move, turn, paint, move, turn, paint, move, turn, and then paint the last square. Let's give this a shot. Ooh, first we have to instantiate the object, which is fine. There we are. And then, PatternPainter. I'll follow what we have been doing for the name. Okay, so what does this do? This is the data type. It's of type PatternPainter. This is the name of the object, my PatternPainter. This says equals new PatternPainter. I'm asking it to go grab this class and run the constructor. This constructor allows us to do everything in this, like paint pattern, and it says super. Super runs grabs whatever Painter Plus can do, so we can do everything Painter Plus can do, like turn right. It also means, since Painter Plus can do everything Painter can do, Super means we can do everything Painter Plus and Painter can do. Cool. All right, that being said, bam. We need paint. Let me check out, how can we give the Painter paint? Oh, they don't tell us. Oh, well, cheat code time. You've seen this in class. There is a way to give our painter paint. Painter paint, Peter Piper. Bam. So this has been in the slide deck in class, of course, several times. These are all the actual behaviors that apparently they didn't tell us, but I want to test this. And one of the ones I want to use is set paint, and you can put in a number how much paint the painter will have. So that's what we're doing, secret menu. I'm just saying 800, you can put whatever, I just want to test this. My pattern painter, paint pattern, whatever color, I'll use red, I guess. Bam. Let's see if I broke it. Hey, that actually worked. Woohoo! I mean, of course it did. All right, like I said, I want to follow them exactly, and I believe, at least for the shape, I'll get our painter right back to where they started and leave it there for now. So let me go back here. Now, how could I do that? If I end here, I could go ahead and move forward again, right? And if I want to face the same direction I started at, turn right. Now, let's think about some efficiencies. So in code, if you haven't heard me say this, if you're repeating yourself, there's probably a better way. Now, notice that we paint, we then move, then we turn right. So if I were to do a loop, like I said, look guys, identical, 4 times in a row. Let's use some type of a loop. So I'll go ahead and throw down a while loop, while, and then I don't know yet, something true, curly brackets, enter. Okay? Now we need a condition. What can I check every time to see if I should keep running this repeated code? That also means I can kill this off. By the way, guys, this was correct beforehand. This is fine, right? But let's be fancy. Let's do things clean, nice, pretty, code. All right, okay. So I'm going to grab this, and actually, no, I'm just going to delete this curly bracket. Bam, bam, and bam. So we need something that we can check. We can't check direction because we're going to be facing east and we're going to not be facing east. I could probably figure out a way to do that. That sounds more complicated. What I notice instantly is that when we start this loop, we have not painted anything yet. We're standing on blank space. So if there's a way to say, hey, are you in a blank area, keep running, that'd be great. Because when we start it, we're blank. I paint it, I move forward, and I turn right. I would then hit the bottom again. I haven't painted the square that I'm standing on then. Right? I painted the last one and I moved off of it. So then I could ask, hey, is the square empty? Or the dot or whatever area empty? And that would be true again. So I'd paint that one and I'd move to this one. And then once I moved to that one, I would turn right, hit the bottom again. Hey, is it empty? Yeah, I would just be standing on it. It's empty. And then we'd move over here. Same thing. It'd loop around. Hey, is it empty? Yeah, it would still be empty. So we could run this again. And then once we're standing back up here, there is paint. So let's take a look. Oh, look, we have has paint. No, that's not what we want. Is on bucket. Oh, is on paint is what we want. Perfect. So if I am not on paint, this says if I'm on paint, right? That's not what we want. We don't start on paint. So instead, I'm going to put an exclamation point. And now this means, hey, computer, am I not on paint? And every time this runs, I'm asking the computer to say, hey, computer, am I on paint? And it says, I don't know, zoop. And if we were starting out, if there was no paint, this would say true. Or if we're starting out and there's no paint, this would be false, right? However, we have not. So now I'm asking the computer, hey, am I not on paint? And the computer, again, only if we were starting out, there's no paint under us. So yeah, you're not on paint. That is true. And we'd run this code. At every turn, we can run it. And then we're back up top. Bam. Clean. And I might update my pseudocode to reflect that change. Bam. You get the general idea. Fancy, fancy. Clean code is great. All right. Oh. Cool. Onward.